Welcome to Chemical Kinetics. What is kinetics? Kinetics is the study of changes in rates of reaction. So, what is the rate of a reaction? So, if you remember, when you were younger, we talked about the difference between ratios and rates, and a rate is a comparison of two quantities that have different units. For example, you could talk about the unit rate of milk, so in dollars per liter, or the rate of gas or any other commodity. In the case of a chemical reaction, we would think of rates as the rate at which a product is being formed, or we could talk about the rate at which a reactant is being used up. Again, you have choices in terms of how do you measure this rate of reaction. So you could think of, you would need an observable quantity that is changing. So maybe the mass of the product that is being formed, the volume of the product that is being formed, you could record the change in pH, conductivity, and so on. What you actually use to measure the rate of the chemical reaction is dependent on partly what you're interested in and also dependent on what equipment you have available. So let's look at some examples of options available for a particular chemical reaction. So if there is a product or a reactant whose volume can be measured, so usually a gas, then you could measure the rate of the reaction in terms of the change in volume over time. So the volume could be milliliters, liters, time could be in seconds, minutes, hours, what have you. If there was a reaction that had ions, then you could measure the change in electrical conductivity over time. So in this case, you see that as time passes on, the number of ions, the concentration of ions is increasing, so you expect conductivity to increase. If the ions were on the left hand side of the equation, that is reactants, and as time went on, if the ions were being used up, you would expect to see a decrease in electrical conductivity over time. You could measure the change in pressure. Again, usually that would mean that there is either a gaseous product or a gaseous reactant whose pressure would change over time. You could, if you had access to a spectrophotometer or a colorimeter, then you could measure the change in light intensity. It is possible for a reactant to be colored. So as time goes on, if the reactant is used up, then you expect the absorbance to decrease, and if the product is colored, then as time goes on, you expect the absorbance to increase. So we will do some reactions with colorimeters in our lab, and we will talk about Lambert-Beer's law as well when we get to that lab. Another thing you could measure is a change in pH if you had H plus ions being produced or H plus ions being used up, or OH minus ions being produced or OH minus ions being used up. So those are just some examples, ways in which rates of a reaction can be measured. I will let you try. So let's look at this example equation given, and you figure out what are some ways in which you could measure the rates of these reactions. So we see here that H plus ions are being used up. So maybe one option is you could measure the change in pH. So as time goes on, this reaction will become less acidic. Why would we want to study kinetics? Well, sometimes we want to be able to control reactions, like you want to be able to slow down a disease, or you want to be able to slow down the corrosion of a certain metal, or you want to slow down the rate at which food is spoiling. Then there might be times in industry where you might want to increase the rate of a reaction. You might want to speed up certain reactions, or you might want to match them exact. For example, a pharmaceutical company would want to be able to control the rate of release of a drug precisely. So those are our reasons for studying chemical kinetics. Now let's look at how do we write the rates of chemical reactions. So the rate of a reaction, as we just defined it, could be the rate of decrease in the concentration of a reactant, or it could be written as the rate of increase in the concentration of a product over whatever time interval you are interested in. So this is often written as a rate equals, so this delta stands for change in concentration of products over change in time. When the rate is being measured in terms of the production of something, it is positive, and when rate is being measured in terms of consumption or usage of a reactant, we use the negative sign. Now the thing to keep in mind is this is saying the change in, so it would be a negative sign, the reactant final amount minus the reactant initial amount over change in time. Now we know that if the reactant is being used up, then the final amount will always be less than the initial amount, which means that this term will end up being negative, which means even though you have this negative sign in the beginning here, the actual number that you use for rate will always be positive. So if you were saying this in words, you would say the rate of consumption of oxygen is 2 moles per liter per second. Okay, so you're saying a positive number, you're not saying negative 2 moles per liter per second, but if you're just writing the rate of consumption of oxygen, or you wouldn't use the word consumption then, you just say the rate of change of oxygen is negative 2 moles per liter per second. Okay? So that negative is just giving a direction of consumption or production. It is not a minus number. Usually when we talk about the rate of a reaction in terms of its concentration, then the units for the rate of the reaction are moles per liter per second.